We are live. Hi. I'm just going to go make a live stream announcement real quick, and then we are going to get to dev. We have a full day planned today. Okay. So here's the plan for today. We're going to get this experience buffer working. We're going to go through a few different permutations of how this could be implemented. I started on this yesterday. I was absolutely exhausted. I went to bed at 7 p.m. and slept till 8 a.m. So I'm refreshed, and we're going to get all this stuff going here. So I realized that I was pretty much correct in the way that I was doing this before already. There are a few small changes that I am going to want to make to this, though. And now the question is going to be, do I make them now, or do I get the current version to run first? I think it's better to just make the changes now and get it working once. Okay. Let me make sure I'm actually correct with how I was going to do this. So the crux of it here is the buffer shape. You see it is num rows by BPT horizon, like so. What I was going to do not quite this. Num rows, batch. It's going to be the number of rows. What is it? No, it's still num rows. It was going to be something like a trajectory segment. Num. Something like this. And then it would be number of rows by mini batches batch length. Something like this. I don't think this is yet perfect either. Yeah, the data structure for this is a little bit tricky. So technically, right, you can have any number of trajectories, any trajectory length, any segment horizon for BPT, BPTT. There's a lot that you need to add here. I guess the two cases that we want to optimize for are like your standard old environments, which are not vectorized and you're not going to be running very many copies of because they're slow. And then the vectorized case, where everything is very fast and you can assume that you're going to get equal chunks of experience from each subprocess. So instead of doing num rows, it's like mini batches, micro batches or something, isn't it? So if I really wanted to do this, it would be like num micro batches, micro batch size. But that's annoying, right? Because now we have this 5D tensor. Yeah, we have a 5D tensor. There's nothing wrong with that fundamentally. It's just very silly to work with, right? Because then you can imagine that all these tensors up top, log probs, rewards, done, truncated, all these, now we're going to have to do the same with these. That's annoying. Yeah, so in this case, right, you'd loop over mini batches, and then you would loop over micro batches with the same LSTM state, and then you would go, take all the data from these, you get micro batch by traj length, and this is your data by ob shape. So that works. I don't like this though. I really don't like this. And the reason that are you ever going to have more M's than micro batch size? You are, right? Yeah, so this is tricky because like what ends up happening here, right? Let's say you have 8192 M's or 8192 agents. You're not going to be able to run optim over a batch of that size, most likely. That's tricky. That was very tricky. It's almost one of those things, right, where you have to build it as generally as possible. Not because, necessarily it needs to be that way, but because you don't know what the correct specific build is, right? Like we might be able to assume that you're always going to have more M's than batch rows or something like that. And then we can kill one of these dimensions. Guess we could time some stuff as well. The expectation I have is that the LSTM, the number of rows in the LSTM probably has to be reasonably large. Actually, it is a fused CUDA kernel. Maybe it doesn't have to be. Should we just test that? Is that going to help us though? I don't actually know what that would tell us. This isn't easy to write to either, right? Yeah, because you need to index. Yeah, this is quite difficult actually to design this. Maybe I should start drawing this so people can see. No, because this is like very abstract. Maybe I should just start drawing this so people can see what I'm talking about, and maybe I'll figure it out that way. I'm going to just download this as a PDF in case I need that. Okay. So here's the issue, right? The thing that we're looking at now, you have experience. It comes in from the environments, right? So each of these is an agent. And then you're probably going to get something like this being like an M step. So you're going to get some group of observations for some of the agents. And then what your job is to do, your job is to turn this into a batch for training. Now, a batch for training is probably, each mini batch rather, is going to contain ideally unpadded fixed length it's going to be like some number of steps. So this is like seg length. And then this is your mini batch. So what's wrong with this, right? Why can't you just grab like this and like this? Well, this segment length is not necessarily the same as this length here, right? You might want to chop this up. And if you do chop it up, then you have to keep track of which M's this belongs to, because this next batch, right, that's going to come in like this, you have to keep track of the LSTM state. Because ideally, you'd like to preserve the LSTM state across boundaries. And it's also not necessarily the case that these are going to be dense, right? Some steps might get more experience than others, right? So like this one here, maybe you're missing a little bit of experience. What do you do about that? There are lots and lots of considerations here. Now, complicating this further, there's also the PufferLib case. So we have two different main cases, right? In one case, we're basically going to get random data from like random agents. We're not going to have that big of a batch size. It's not going to be super fast so that we don't have to worry about overhead. That's like working with Atari or working with any classic. I almost should start calling them legacy M's with how fast Puffer is getting. But the other case is working with PufferLibs. And in PufferLibs, you get lots of nice things for free. So in PufferLibs, I can basically guarantee you that let's say that you have this buffer and we just like look at this block and this block here, you're going to get a block of observations here, and then you're going to get a block of observations here, and then here, and then here. And these are going to fill up, you know, these are going to fill up perfectly. And you're not going to have weird like agents indexed where batches are split all across this buffer, and things are going to be relatively nice. You're going to have relatively large batch sizes. You're not going to have to deal with padding. You're not going to have to deal with weird indexing. Things are just nice. But this doesn't hold for the other case. So your goal here is whatever I build, I want this thing to be very nicely indexed such that we get minimal possible copy overhead and such. And then the jank buffer right? This is like what an Atari buffer might look like, where it's like stuff's all over the place, right? This one's allowed to be slower because a small amount of overhead here, you're not going to notice it because the ems are slow anyways. And they're going to be by definition. They're not really properly vectorized. So you need to optimize for both of these things. Now, I'd also like to optimize this such that it is relatively efficient to use an experience buffer of some sort. I should clarify that, to use a prioritized experience buffer of some sort. This is also tricky. So a prioritized experience buffer, basically by definition, is going to require you to do additional copies. Because you don't know what the priority is of each of these samples until you have the whole sample collected. There is an optimization I can make here. If I know that I'm going to have to copy the data anyways, I can keep the full segment, right? So we'll just have this be a full trach or full segment. Okay, I was worried about this because technically you can have BPT horizon lower than trajectory segment, and then you'd have to like turn this into 3D, and then there are other things that make you turn it into 4D. So we can actually keep this relatively simple. That actually simplifies a lot. We do incur an extra copy, but there's no way around that extra copy, I'm pretty sure. Okay. Now the experience buffer is going to have to work a little differently. Is there any reason to have a lower BPT horizon versus a higher one? I used to think it was O of n squared, but it's not. It's O of n. Does anybody know? Would there ever be a reason that we need BPT horizon like 16 instead of 128? Like, I'm thinking here, right? And it seems very unlikely to me that we're really going to ever want to scale to giant batch sizes because of hardware efficiency. Well, that's not true. To giant unroll lengths. I don't know, at least for impulse boards, a higher BPT always seems to do better. Maybe if your episodes are super short. In this case, if the episodes were super short, then it would just end up packing multiple episodes into a single buffer length, and that's not really a problem. The only thing that happens is that you don't get to reset your LSTM state between episodes, and that really doesn't matter. Also, welcome, Captain. I'm back for the next 3 weeks or whatever, so I will be around to look at any code as is needed. This week, I think most of this week I'm going to spend really trying to clean up our trainer so that we can have, basically so that we get close to something in the releasable state. Yeah, we're going to have like a nice stable dev branch so we can like finish up all the experiments and start thinking about a release. A lot of work to do for that. I'm trying to think if this is ever going to bite me. I think the only time you end up with shorter BPT horizon is when you're collecting shorter segments. So I don't think this ever really bites you. Design for prioritized. Yeah, so we're redoing the experience buffer, and the goal is to co-design the experience buffer with prioritized experience replay so that we end up with a simpler, faster, lower mem copy overhead buffer. Basically, we're trying to build a god buffer. Like everybody always has built buffers. We're trying to build the best buffer. Any ideas on giant paragraph from Spencer there. Any ideas on speed improvement for network design below? Okay. Wait, when I have features encoded like a channel versus flat, I go from 1.1 mil to 550K. Currently with point and quarter 550K, with flat features 1.1. Let me see what you did. Let's help you out here. And get Tokyo Puff going. We get a 1.1 miller. Hang on, where's this thing? Bottom. Okay, so this is the flat one, presumably. Yeah, this is flat. Let me think about that for a second for you. Resume flat. Well, if you think about it, flat's a little tricky. So the flat encoder, it has to learn basically the same representation for each point. You're asking it to learn the same set of weights for each point almost. Which is like, you may as well just have it learn those weights once. The tricky thing though, right, is it's only doing, it's like 4 to hidden state, I guess. Wait. Hang on, shouldn't that be strictly better? What's the projection dimension here? So you do ego encoder Is this the road encoder? Hang on. So this is linear relu linear. But in this case, this is 5 by 64. This goes to CNN channel, which is 64. And then this one is, yeah, okay, I see. How many weights is that? Let me see. So it's 5 by 5 times 64. Let's figure this out. So this should be 5 times 64. This is this one here. And then it goes to 64, I guess. Okay, and then the other one is 5 times 64. Well, it's 5 is the input, and then 64 is the output. 64. It's the same number of weights on the input. The input should be the same speed, shouldn't it? Oh, I see the issue. One of these networks is way bigger than the other, Spencer. Isn't it? We're not networks. One of these is using way more flops than the other. So I draw this for you. So you have, this is the flat one, right? And you do like, I guess to this size here. So you do like this. Okay, and then this other one you have like, or no, like this. And then it does like this. Bam. 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 So I'm pretty sure these are the same sizes though, right? So the first layer, it's either smaller. Yeah, but they're processed separately in parallel, right? It's separately but in parallel. And I think it's the same size because this is like 5 by 64, right? And then this goes to 64. And then this is 5 and it goes to 64, but you do it 64 times. Right? Yeah, so this should be the same. Unless I'm wrong about the, hang on, is that how matrix multipliers work? Let me think. That might not be how matrix multipliers work. Let me think here. Because it's technically, what's the squared dimension on a matrix multiply? Because it's cubic, right? But that's only for square matrices. Let me think. So it's input. Each input gets applied to Okay, I'm gonna look this up because the brain not working right now for this. Matrix computational complexity with, or actually no, I'm stupid. It's matrix vector, right? That's why I'm getting confused. So vector matrix complexity vector size m matrix size. What is the weight size? It should be, this is going to be m squared n, isn't it? I just want to make sure I don't get this wrong. Ah, see, I'm stupid. There you go. It's mn. There's no squared term. Why would there be? Yeah, so if there's no squared term, then I'm right. Then these two should be the same number of flops. But the thing that you missed here is the second layer. The second layer is a different number of flops, because in the first case, you're doing 64 by 64, and in the second case, you're doing 64 times, right? 64, however many road points there are, assuming 64 road points, 64 times 64 times 64. So that's what you're missing. So what I would suggest that you do for now, and this will take you all of 5 minutes, is put the max like after this instead, and then retime. Put the max after one layer. So you did right here. There's a discrepancy. Yeah. So you, like, these two networks are not analogous, because what you did here, right, is if you look at it, this first layer combines all the information of all the points, right? This first layer combines all the information of all the points. But here, you gave it an extra layer. So this is actually, this should be a stronger network than this one here, but it's going to be slower, because there's a huge additional ask of flops right here. This is a lot of extra flops. So I would do the max here, and if this makes the network way weaker, then we go back to something like this. But at the very least, like, this is not apples to apples. So the apples to apples here, you would have to make this, you'd have to make this dimension here way bigger or something. Like, this would have to be a bigger linear layer so that it doesn't have to compress everything on the first layer. And that's still not quite perfect, but that's as close as you'd be able to get it. 50% slower, but adding max. 50% slower, but adding max there reduces operations. Wait, 50? I don't understand the comment. So max here is slower than max here, because you're doing 64 times the number of forward passes on this layer. Right? Difference between the two versions right now is 50% slower. I'd have to look at the rest of the network to see if I think 50% is reasonable. I mean, first principles, it could very well be, because this is a tiny network, and you're basically doing 64 times the number of forward passes in this right now. This is a big increase in complexity. Just like run it, right? It'll take you 5 minutes to just flip it around and run it. And if it's still slower, then come back and we'll chat about it and we'll figure out what we can do. But that is kind of the standard entity encoder style network. Okay. Back to experience buffers. How's Max there change things? Sorry, still lost. Okay. Let me see if I can explain this. So what you did, right? In the first one, yeah, I'll explain this real quick. So in the first one, right, you take your encoder, you have all these big observations, and you encode them to 64 by 64. So or 64. So this is 64. All right, and then you do 64 by 64. Right. So if you have one sample, this is now a 64 vector to a 64 vector matrix, right? So it looks like this. Okay, but what happens on this other one where you do all these little encodings? This is a batch, right? So you do like all these little encodings. What you end up with here is not a 64-dimensional vector. This is excluding the batch dimension. So we're not even talking about the batch dimension. This is now 64 by 64. Okay, and then you're doing a 64 by 64 multiply. So this is n squared. This is n cubed. Because you still have all the road points, right? You haven't maxed over them yet. Doing the max on N2. Well, you do the max after this, right? And then you do max here. So the output of this, hang on. So the output of this here, this is going to give you 64. Or, hang on, this is 64. The output of this is 64 by 64. And then you do max here, right? To get 64. So this operation here is 64 times more expensive than the operation here. So placing it earlier achieves a similar effect but less multiplies. So placing it earlier, essentially the networks become the same after the first layer. So you do your combine operation in the first layer, because this does the combine in the first layer, right? This top network combines all the information from all these points in the first layer. Once you go here, you can no longer distinguish between points. In your network here, you can distinguish between points until you do this max over here. I'm not saying that this is necessarily even a bad architecture. It might be that this architecture could end up being essential, even. And this is what you would do if you wanted to scale your network up a little bit without increasing parameter count or whatever. But it's 64 times as expensive. This layer is. Now, this layer is only a small part of your whole overall network, so it works out to be about 50% slower. And you also kind of get economies of scale because GPU go burr. But that's what you're doing right here. You see? If you max here instead, if you max right here, I don't know why I wrote name instead of max, then you get a 64-dimensional vector. And now this is exactly the same as up here, right? That's the key. Do you see how I think about this now, though? It's not even that your network is bad. It's just that this is going to be way more flops than the top one. Quick follow-up. GPU group does TANH instead of ReLU and add normalized layer between linears. Any reason for me to do that? I've seen that in robotic stuff before. There's something to TNH over Relu because there was like this big control study where for some reason it was better for control problems with continuous outputs. Um, I have no idea why that would be better, and it's kind of sucky because like TNH is just a shitty activation. This is what we used back in like 2015 or before 2015. We used TNH just because we didn't know better, and then the layer norms can be very slow. So they said that they were really needed in order to make their stuff work. Do I trust that it wasn't just bad hyperparameters? So like this was Band-Aid patch for bad hyperparameters? No. It could very well have just been like Band-Aid patch for bad hypers and whatever. Now, which would be fine if it weren't slow. And I think it is going to be slow. You can try it, but if it's slow, that'll be expected. TNH shouldn't really be any slower, but yeah. I'm also going to be interested to see if like there's a big difference in perf now with Muon, because Muon should help smooth some of the quirks that we were getting before. Okay, are we good on this though? We just ban that bot. Sweep with Muon. Yes, good. Okay, solid. So my goal for this week, Spencer, is I'm going to try to get this experience buffer and the training code into a spot where it's not insane. So like you'll actually be able to do stable work on it. That's the goal. Mind taking a quick look at multi-discrete actions. Sure. Oh yeah, also I think you both probably saw, but I posted in the Discord one thing. Oops. So I just had to answer something, and I think you both saw, but this is what I was looking at over the weekend. This is the capacity right here for new machines. We're gonna have 2-foot, like just storage racks in front of these for desktops, 40 ports, and then there's going to be a 42U rack sitting right here where we can stick any server grade equipment. If we get any, we can stick right in front of there. And it'll all be on a UPS, so we won't have screwy like power out drops screwing us over anymore. We might still have internet bullshit because we cannot get a 10 gig line to the facility. So we're gonna have just a 1 gig line to start with, and then I might just get like extra Starlink backups because that's not gonna be enough bandwidth. It is. It's a pretty huge UPS. It's a big box. Yeah. So we get this, and then all the space that is not being used by servers gets used for gym equipment. So a facility also gets to be my gym. It'll be fun. I'm having a good time going through and like figuring out what to order for it. And this will be ready in about 3 weeks. Don't drop weights on the servers. The entire floor is going to be 3/4 inch rubber mat. We're getting the mats installed in probably 2 to 3 weeks. So like that's solid. That's a solid chunk of rubber. Yeah. 3/4 inch, yeah. So I went extra heavy on it just to be absolutely sure that we will be good there. I might even have to do something thicker for the deadlift area. But we'll figure that out when we get there. I'm not really deadlifting any reasonable amount of weight at the moment, so no problem for a bit. I'm just trying to get my body weight back. But yeah, that's what I've been doing. Let's take a look at your sweep. Okay. It's a cool sweep. This is Impulse Wars. Looks like it. Very high gamma. That's somewhat expected. We might even want to increase maximum gamma for you because it's this high. Lambda. Yeah, lowish lambda. Oh geez, you really cranked this thing. Does this even work? You have to have a really large batch size for this to even... that's interesting. Yeah, I know. I did both of those dashboards right in my setup. I'm looking at this first. This actually, yeah, this appears to keep doing better. M's. Very small number of M's, though. Is this the, you probably have several cores here, right? So this is probably like M's per core. And you probably have like several cores, right? Mini batch size 8192. 16 cores, yeah, so that's a good number of environments then. That's, what is that, 2048 M's for this? That's reasonable. Hey, you can share your absolutely god-awful learning curves and win a gift box. So we just submit them our entire sweeps on everything. It's like, yeah, this is just daily life for us, thank you. See, stuff like this kind of bothers me. Stuff like this kind of bothers me. It really shouldn't be this sensitive to a little bit of entropy. Right? So it doesn't even bother me that it does... Like, I don't even, like, expect to do better with some entropy, but, like, it shouldn't crash learning with entropy. Like, you should expect this to kind of be flat right here, is what I would expect. I would expect some runs with, like, decent perf at slightly higher entropy. It's very sensitive to that, which is concerning. This is, like, better, right? This is kind of like a flat region here. You can see kind of like you want to increase your value function coefficient, but it's kind of stable over here. Oh, and then we're still at like baby levels of time steps here. 600 million? Get out of here. I did a 5 billion step neural MMO sweep over the weekend. Each run was 5 billion steps. With bigger networks as well. Multi-discrete without torch compile. So we'll have to fix that. I thought I merged that PR from that guy. Did that not help? This is still going up, though. You can just keep this going. $60 to 80%. Okay, so that's weird because I don't get anything out of torch compile in my setups. So something screwy is going on there. I don't have continuous actions. I have discrete actions, and I don't get much from compile at all. It's often slower, in fact. Entropy. Cool. Looks like a very reasonable sweep. Was there anything in particular that you're wondering about? Because this looks... I mean, what you want to do is you want to go over to here. And then what does it win? Little concerning how shallow some of these curves are. Not on dev. Okay, so I probably just something broken then. We'll have to sit down and find that at some point. Like I said, I'm around all week. I have, or next couple weeks, I've got pretty much nothing planned than just solid dev. And then I go to the warehouse, and then I have absolutely nothing planned but just solid dev when I get there. Hang on a second. Oops. Okay. Had to answer a thing. Mostly, I was curious why ent was so low, and if I should do a new sweep with increased backprop horizon. Best runs mini batch seemed low to me. Yeah, that'll happen. You just use... I think that the best thing you can do, Captain, is you use the parameters that the sweep tells you, and you keep improving infrastructure. I have noticed as you improve infrastructure and things that are fast, that should be fast become fast, the hyperparameters get better. Because you have to remember the access that it's controlling is wall clock. So like some part being slow that's not supposed to be slow can actually change optimal hypers and make things unintuitive. I am a little suspicious how shallow these graphs are. Oh yeah, what's your SPS at? Oh. 100 to 250K? My guy. Oof. That is rough. I'm pretty sure I'm running 3 million parameter nets. Twice as fast as your fastest run here. You must be hard env bottlenecked, right? Or are you net bottlenecked or env bottlenecked? What's the dashboard show you? 320. That's still low. So you've got 500 seconds env time. You have a crazy amount of copy bandwidth right here. Your env actually is not big. Like, this is not... Yeah, your env time, you're not even bottlenecked by your env here. Look, you're getting screwed over by copies. I'm going to improve that a little bit for you, but you also need to check the size of your data packets there. So this is probably, what's that, 20% of your eval time spent in that. And then, let's see, MISC is good. 63, yep. That's still not crazy, though. Oh, you have, like, 0 learn time. Wait, what? Nah, I don't know what the heck the solution is here, but something's just trolling here. This is, like, hard trolling. 1E3 train. And 6E3 eval. So more than 80% time spent in eval is hard trolling. Yeah, that is hard trolling. My guess is, if I just pick a random one of these, there's something wrong if multi-discrete actions are that slow. I mean, that's like a trivial operation. Let me check something real quick. 4 env batch size. Wait, 16 ems. You have this quad buffered. So that's only 512. You only have 512 batch size in the forward pass. You're definitely not going to load the GPU enough with that. I'm guessing that you have it quad buffered because when you double buffer it, the env percentage gets to be quite large or something. At 300K is still not considered reasonable, Captain. Like, we really should have this thing at 500 plus. If I can have neural MMO at 500 plus, we should be able to have this at 500 plus. Like, here, I'll show you my... Because I have a bigger net as well. I guess this thing crashed at some point, but we got 24 runs in here. A couple of these actually did okay. A couple of runs did okay. Where's my SPS? So pretty much all of these are at 500K. Eval 4 does a no op. I think I just get 500K. Well, then the question's going to be why, because you have 16 cores. With Puffer, you should be able to get pretty damn close to linear speed up. So, unless the env is running at like 30K, you should be able to get faster than that. Right? And this is, again, this is with a big network as well. Like, I think this is with... Where's hidden size? Yeah, so this is with a 512, 512 LSTM. Forward pass is the big one. M speed was not your biggest line item at all. I checked your perf, right? Your line, your M speed really wasn't that big of a deal. It was a pretty small fraction. Your copy time was bigger than your M time even. So I'll help you play with that. But definitely we need to do some stuff on that. I think what we're going to probably do is I'll do, if people aren't free in the evenings, I'll do some calls, during the day. But I'll try to make myself more available than I've been doing in the evenings, to chat through stuff, over dinner and then after dinner. Continuous action, so that's more accurate to when torch compile works with multi-discrete actions. The thing is that we should just be able to make multi-discrete fast. There's no reason that should be slow. So I'm believing you that it is slow, right? But there's no reason that it should be, so we should just be able to make that fast. 300K. Yeah. Anything else I can do right now for you, Captain? Like, that's a reasonable sweep. I would just, keep running that stuff. Like, what else do you want to do? We can save this for, like, a later conversation, but, like, start thinking about, like, what you want to do with Impulse Wars before you release it, right? Is there more content that has to go in? Is there UI stuff that needs to be cleaned up? Is there perf stuff to do? Or do you, at this point, just want a really strong baseline? That's what I would encourage you to do. Like, think of like, what you want to do for the release of this thing. Use small things for 3D graphics and then baseline. Gotcha. So, I mean, I can show you some of the stuff I've done for the Neural MMO baseline. Are you on the latest code with Muon and everything at this point, or no? Okay, good. So if you're on the latest code using Muon, then you should be able to get some stable runs. And the only thing that's really hamstringing you should be the M speed, because, like, billions, not hundreds of millions. Old bindings aren't really going to give you any speed. Bindings are just going to simplify things. I could be wrong, but I haven't seen major speed ups with bindings. Neural MMO got like 5-10% faster, and then like Pong got a little bit slower. I think Neural MMO is probably the better comparison, so you might get a little bit of speed. I think you get link time optimization now as well. You don't screw up link time optimization anymore. My next week. Yeah, you can just bump it up. You can bump that up, it's fine. But, like, honestly, I did a fixed 5 bill sweep lately for Neural MMO. That did okay. And then I start doing, like, some individual experiments. So, like, do you have a 256 hidden dim already, or do you have 128? Because 128 is probably too small for that problem. I got a little bit of perf out of doing even 512. 256, okay, good. I bumped Neural MMO up to 512, and the network really wasn't that much slower, and I got a little bit of improvement out of that. You got to make sure that you're not bottlenecking your network by a very small, like, number of con filters or something. You got to make sure that whatever's coming out of the CNN isn't tiny. I got a little bit of perf out of dealing with that. You might need to look at your seeding. I got a little bit of perf out of fixing my seeding. Sweep over hidden dim. I don't know if you'd sweep over hidden dim because like I technically have it in place that you should be able to, but there's still some screwy things with that, especially around memory usage. So I probably wouldn't do that. You can kind of just run one sweep at higher hidden dim and one at lower. Yeah. I'm chatting with someone on the side who's done similar experience buffer stuff. Five 12 hidden dim, try messing with CNN. What else? You can look at some of my latest Neural MMO 3 sweeps, I think. But I like those were the big ones. The only other thing that I had to deal with was seeding. Seeding actually made a decent difference. I just added that into the new binding code, so you're not going to have access to that yet. Um, if you really want to do something short term with that, then you probably just need to find and I didn't do this because it's slightly annoying, but if you get the clock time in nanoseconds instead of in seconds, you should be able to guarantee unique seeds for all the M's. Um, I think basically what happened before is that because I was using time in seconds, all the maps were getting the same seed. You got to be careful with that. That made a decent difference. If you're using a random seed for every process, you still need a random seed for every environment, right? I guess it kind of depends. Incremental. Okay, if you're already seeding, then that should be fine. Yeah, if you're already seeding, then that should be fine. Well, this is a lot of the science side stuff, right? These are the harder M's. They're going to take a little bit of work to get to be, nice and functional. And, I mean, kind of in my head, though, once we have, if we can, like, get clean RL, like, just clean, simple RL working on your env, on Neural MMO 3, maybe on a couple others, maybe on MOBA with self-play, not just against shitty scripted bots. That's kind of like good for release and probably already better than a lot of the problems in industry. Like, frankly, there are a lot of valuable problems in industry that are just flat out simpler than Impulse Wars. They don't look like games, right? But the actual learning dynamics are way simpler than your problem. So I think that'll be the next milestone goal, right? Is we have solid simple RL working on your env, working on my env. We ship your env, we ship my env, we ship some of the stuff Spencer's been doing, and that's the next release. And then we'll see what we do from there. From there, it depends on how much stuff is left to fix versus how much I'd like say, okay, let's scale this and now get some industry contracts going. Sucks because continuous actions are much faster. Well, we'll just fix that, Captain, because they shouldn't be. We'll just fix that. Is this going to be the NeoVim tweet? Am I terminally online and know the post? Oh no, this is another one of his memes. Yep. Yep. The funny thing, Tyler, is like I'm way happier and way more productive when I just turn off X and I just stop interacting with shitty programmers with absolutely terrible tech takes. That's like literally that's all there is to it. Like they post all this progress, but it's all smoke and mirrors. Like of course they haven't built anything because they don't know how to build anything. It's all lies. Like it bothers the hell out of me, but you can just turn it off and you're not missing anything. Impulse Wars better not be 100% vibe coded, Captain. Ugh. Yeah, exactly. I'd know because I'd have criticisms of your code, not just the box 2D. I still think, by the way, that because of the way box 2D is designed, there's probably twice as much code as there needs to be in Impulse Wars. There's like a massive amount of boilerplate there with the way that physics engine is set up. So I still think that's the case. I think the box 2D internals are very good. Aaron seems to know what he's doing on the internals, but definitely the interface of it is a little bit. It's a little sus. It's like a suspiciously high level interface for a low level library. All right. Yeah. I mean, I don't know. I know I get very pedantic over like code length and code quality stuff, but it really makes a difference. Like, it's kind of like the recurring cost of your library is the number of lines of code, or like I guess the complexity of your code is the recurring cost of like maintenance and changing stuff and what it's like. If you can solve a problem that would be like that Fang people would take 1,000,000 lines of code and you solve it in 50,000 lines, like you don't have the same thing, right? Yours is infinitely more valuable as you can actually do stuff with it. Plus, you gotta have some self-respect. Okay. Does anybody have any other things for me to review right now, or can I get back to doing the experience buffer? Makes sense to only keep pure RL eval training and move other stuff to other module. I was thinking about doing the opposite. I was thinking about combining the demo file with clean PufferL and then just working really hard to make that file shorter. Hiding code in other files doesn't make it shorter. Logging, for example. So, the reason that there's nothing fundamentally good about putting all the code in one file, right? It removes a few lines of imports. That's it. The reason I tend to do it is because when you have all your code in one place, it makes it easier to see that you're being stupid when you've missed like co-optimizations where like if you have module A and module B, it needs to be a lot of code, but if you just redesign them into one thing, it's shorter. That's why I do it. Um, yeah, that's why I do it. I'm gonna take a pass at like redoing a whole bunch of this stuff anyways, and then we'll see where we end up. I'm hoping we can just make a lot of it shorter anyways. But I don't see why like I don't know why we would put stuff that's only ever going to be useful for clean PufferL that's been designed specifically for that trainer into the internals of PufferLib. Heck, there's a lot of stuff in PufferLib I just like to straight up delete. right? I'd really love it if we got to a spot where like puffer core is a few thousand lines and like a very small number of useful tools, and then all the work kind of starts being more and more low level stuff in C, more like shipping our own CUDA modules, more stuff like that. Aside from the obvious algorithmic work. All right. Anybody have any other stuff, or do I go back to experience buffer? Because experience buffer is going to be hard, and I want to actually be able to focus on it for a few solid hours. Okay. Likely we go back to experience buffer. So, let me think. We've kind of figured out, let me just read this one message. This other guy can't really tell me that much about what he's done, but somebody did a buffer. Before you start back, has anybody got priority experience buffer working well with on policy? I don't know if they have in the way that I'm doing it, but basically, one of the things I figured out over the weekend, yeah, let's just say that there's going to be an article titled On Policy Learning is a Lie coming out pretty soon. Let's just say that. I looked at the math a bit, and it don't make sense. So that's going to be fun. Ventral protein. There'll be some articles. I don't mind writing blog posts now and again. I just hate writing papers. So there will be, my guess is there's going to be like a series of blog posts with the 2.5 release. Plus, you know, it's actually useful. Whenever I write like long form content on X, a good chunk of the time it blows up. Like I didn't even do an article, but I did, I got really annoyed by this insane doomer like blog post. It was literally kind of like a hit piece by like, I don't know what the hell it was. So I wrote a big thread on it, and it's gotten 77,000 views, and like 3,000 people actually read the entire 25 tweet thread that I wrote. So that was kind of cool. So long form content, good. Okay, back to experience buffer. Collect segments. Now, for the prioritize buffer. So each of these is going to get a score, which is going to be based on the advantage. Is it even worth looking at reference implementations for an experience buffer? Because I'm pretty sure they're all like I'm pretty sure they all suck. hang on, the advantage function, can you use the advantage function for experience prioritization? Okay, so we have this and we have this. I guess the torch one might be half decent. Let's see. So this is the original experience buffer. How much prioritization is used? Important sampling negative exponent. Added to priority is storage. List storage will be used. Well, that's horrifying. That's like the worst thing ever. Pin memory. Prefetch. Number of next batches to be preset fetched using multi-threading. That's useless if your memory's on the GPU, right? Yeah, that's useless if your memory's on the GPU. Transform to be executed. Okay, that's horrible. Don't do that ever. Batch size. Dim extend. Yeah. Let's see if their code's any good. Oh wait, is there more docs? No, it's just this. Replay buffer. None of this is in C++, right? I guess it's relying on TensorDict, but that's still not great. Only loops over dim so far. I don't see loops over elements. Okay. What's this? Prioritize replay buffer. Oh geez, remote buffer. And that's not good. That's slow as hell. I don't see anything in here that makes me think I should, like, pay any attention to this. So let's go to the actual paper. It just doesn't look very well built. Where's the math for this? Prioritizing with TD error. Expected learning progress. Magnitude of TD error. It indicates how surprising or unexpected the transition is. So this would be very closely related to what I was considering, which is using advantage. Because In PPO, we have some advantage function, right? And where is it? Yeah, this here, this is TD error, right? So for gamma equals 0, or it's at lambda equals 0, generalized advantage estimation just gives you TD error. And then for 1, it gives you value baseline discounted returns. Now the thing I'm wondering here, this is only really based on the value function, right? Oh, but wait, the value function is, in a sense, conditioned on the policy, right? Because the value function is not just telling you... Yeah. Okay, so what I was concerned about is that if I use the advantage function in order to prioritize experience, then it could be the case that the value function learns the correct return out of it, but the policy hasn't actually done anything. So that's not the case because the value function... Well, first of all, the reward collected is actually the reward collected by the behavior of the policy. So the policy is correct in a sense. The policy is always correct because that's the only sample that you see, is the sample that you get. So the only thing that can be wrong is the value function here. So you are, in a sense, just training the value function, and the value function depends on the policy anyways because that's what collects the data that it sees. Okay, I'm happy that you can use this for prioritization. That is fine. So then what you could do is you can reprioritize every time you do an update to the policy. You can reprioritize the advantage buffer. That would make sense. Yes, that would make sense. The reshape for this thing... Well, hang on. Getting ahead of ourselves. We collect data in batch. Now we need prioritized data. How do you want to sample from this thing? Is there ever a reason that you would want to train on... You never want to train on low priority samples, right? So the data in this buffer is going to have to be constantly shifting around. I think you're screwed on memory contiguity here, though. I think you're screwed on memory contiguity. Yeah, so the issue here, right, is you get these samples on policy. You've got like some other samples here that are off policy. And then these got to get blended into like some samples. We'll call this A0. Okay. So here's your buffer. But you don't just iterate over this buffer. you want to sample from it the top n. So you actually need top k. And this is going to be a non-contiguous sample. And even if you were to sort this by top k, then you have to reprioritize. Right? You have to reprioritize. Okay. Hang on. We can save a copy. There is a way for us to save a copy. If we just make one big buffer, right, we just connect these two. And then at the end of a whole training loop, we just make sure that we have these samples at the end. Then we're good. If you want constantly correct prioritized samples, there's no way around this. Oh shit, wait, it's harder than this. Every time you do a sample step, you have to reprioritize everything, don't you? How bad is that? So every time you do a mini batch, you have to reprioritize all the samples. I think I can make that fast. If I do a CUDA kernel for this, I think I can make it fast. So you just need CUDA GAE. It doesn't have to cross segment boundaries. I can definitely make that fast. Okay. Well, we might find out that I'm crazy with some of the assumptions I've made here. There are several ways at a hardware level that this can go wrong. But if everything works out, this should be pretty simple. This should be pretty simple. And then this would give us prioritized experience replay. There will be copy overhead. The copy overhead is at a trajectory level, which is nowhere near as bad as at a sample level. Previously, we were doing sample level indexing. So we actually have more efficient by a factor of segment length indexing now. I think this works. This gets us 2D tensors for everything. 2D tensors for everything. This gets us prioritized experience replay. This gets us non-prioritized advantage filtering with the same code very easily. This gets us a lot. This gets us a lot, I'd say. And actually, I think for anyone watching with RL experience, if you know whether you use both high advantage and low advantage trajectories in experience replay, I'm actually not sure. I would think that you would take absolute value of the advantage or whatever. You would want to have. You would want anything that's surprising you would want to learn on. So you'd learn on really low advantage and really high advantage samples. Because advantage is not, you don't take absolute value by default. So we would want to take absolute value. Okay. I think we start on this. This is not going to be, implementing this, unless I've miscalculated, shouldn't be that bad. And this is actually going to even be a little simpler than our current implementation and will be much, much, much better if I'm correct on all the assumptions. So we don't have to do any of this micro batch, mini batch shenanigans. All we need to do is do batch size, replay size. We need to add one parameter, I believe. We need to add just one parameter. And I think we want to make it a factor. Replay size, factor times batch size. So num rows is going to be batch size plus. I don't know why I did -1. Hey, welcome, Hadrian. Currently, we are coding up prioritized experience replay for PPO, which will be a fun thing to do. Well, not really, but hopefully the results will be fun. Don't need this, don't need this, don't need this. What are you on? What do you mean? I'm currently on one big cup of coffee, if that's what you mean. I guess this does limit non-LSTM models the way we have it here a little bit. What are you working on? Yeah. Experience replay buffer for PPO, prioritized experience buffer. Okay, the only bad thing that I can see with the way that I have I suggested, or I have this implementation suggested, is that technically right now you can only prioritize segments. You cannot prioritize individual samples. Do I care? How bad is that? probably really don't care that much, right? Like, yeah, technically, in theory, that could make a huge difference for non-recurrent models. But any problem that you can solve without memory, like just as well or better, is probably a really stupid problem. I can't think of like any big problems that have been solved without an LSTM. It's usually people like not using an LSTM on Atari or something because like they don't know what they're doing and their LSTM implementation sucks. So I think that we don't care about this. I think we're good. I think we just proceed with plan. Okay. Do you need episode length still? You still need episode lengths, you still need episode indices, you still need all these variables, but it gets a little easier. Yeah, it's a little easier. And then I need to change, before I forget, the full function. On policy rows. We'll just do on policy rows. There we go. So now we have everything. And this full function works as before. I have to edit the Python a tiny bit. This is now 0. This gets commented. So we no longer need to bootstrap across segments like crazy. I gotta tell you, it makes a world of difference coding on 13 hours of sleep versus 4 hours of sleep. Everything is so much easier today. I say as I make a stupid error. I pretty much crashed at like 7 p.m. last night and didn't wake up until 8 a.m. Exhausted. Alright. Now all we have to change is really the sampling, right? When we do like this flattened batch thing. Like this is no longer even a necessity. Like this literally doesn't matter anymore, right? I guess we pack everything into a namespace or whatever. Okay, so advantage is here. I need to do weighted choice, right? Is it weighted random sample? Utils data weighted random sampler. Is there a weighted, is there just like a weighted sample somewhere in here that we can just apply? Or does it only work on a PyTorch data set? Oh no, this just gives you, yeah, this just gives you indices, so this is perfect, right? Wait, this is a function, right? The way that they're calling this? Okay, I don't know why it's named in uppercase like this, but this is just a function, so this is what we need. And I don't think you need to give it probabilities either, right? Yeah, these don't have to be probabilities. So this is advantages, n. Replacement full should be faster. And then generator none should be default. Oh wait, no, replacement true should be faster. Yes. Yeah, there you go. That's just this. So then you just do weights. Or this is indices. And now, all we have to do is it that easy? I think it actually is that easy. That's kind of embarrassing. So we need advantages. Just equal advantages. X actions. Log probs. Dones. Obs. Then you need values and returns. Which is B advantages plus B values. Equals advantages plus values. Okay, so it's something like this, I think. That's it. Yeah, so this is going to have to change massively. Massively. Because You no longer even have update epochs with this, right? I guess you just do it here. You literally just do it here, don't you? Yeah. Oops. So you gotta have experience values, you gotta have all this stuff. And then you compute the JE and to so now we have all this data. This feels wrong, like the amount of changes we're about to make to this trainer. It's gonna get a lot simpler though. Let me make sure that that with statement is lined up. It's not, right? This needs to be tabbed in. Not many batches. Oh no, that's correct. That is. No, it needs to be tabbed in one. It does need to be tabbed in one. Okay. Yeah, there we go. Hey. This total mess of code that you're seeing here is not what this is going to look like when we ship this, by the way. If you look at our current trainer in 2.0, the code is way better than this. This is what happens with like 3 months of me trying a dozen different methods to improve various things in RL. And we're not even going to keep all these flags in. We're just going to drop everything that doesn't immediately work well. And, you know, we're going to have PufferLib should be optimized for like the defaults are good, right? There will have to be like extra features that aren't on by default will have to have a damn good reason for being there, basically. Are you still planning on trying to flesh out P3 at some point? Yes. That is, so to give you an idea, the main thing in PPO right now that is holding RL back is JE. We'll see whether I got it right with P3O as the successor, but that thing needs to be fixed. RL will be stuck until we fix that thing. I'm a little iffy on whether I'm close or not with P3O, though. It might be that I went a little off base with it. We might have to do a little bit more work to get that to function. But it's fine. We'll deal with it. All right. I think we are almost ready to just start debugging this. Explain variance has been, yeah, I took it out of logging because there's another thing that I broke relating to that. It's not that explain variance is wrong, it's that the log is not being populated. I also never look at that log. Maybe I should, but I never look at that log. Okay, so this is an indexing error. Okay. This is 2,000 things, and this is giving me 64 things. And L is out of index. So this needs to just go down, doesn't it? Until here, maybe. Okay, and then we get the same error up top. I notice we don't reset. That's got to get reset right there. Or maybe not. Okay, so we have full indices here. $16K F lengths, 4096 F indices. So, yeah, this is not full indices, right? Or is it? Maybe it is. Maybe this needs to be LSTM total agents. Maybe I have the wrong size. I think I do. Morning, how's it going? Doing pretty well. Back from little trip. Got a bunch of good rest in. Pretty well recharged. And this week we are going to get prioritized experience replay into Puffer. We're going to get this horrendous dev branch code cleaned up. Cleaned up dramatically, I would hope. And we're going to keep running experiments on all the more complex M's that we have, and hopefully get some more soda results. I've got pretty well, I have the next like many weeks of my schedule blocked nicely, so I should be able to focus very well on work. Where did I go? Went to tour the new Puffer facility. I will be there in person in a few weeks again, but in the meanwhile, this is where all the machines are going. We've got electrical done for it. Haven't bought all the machines yet. We'll move some of the ones that we have now here in the short term, but we will be buying a lot more machines. We now have capacity for more machines. We will no longer have to deal with power fluctuations and other bullshit, and we should be able to power a lot of good RL research. Majority of that cluster is going to be, like the vast majority of that cluster is going to be just for all the people we have on open source work, doing more open source work. So hopefully we'll even be able to grow Puffer to a larger open source project with this, because we will have more machines to give people access to. So it'll be kind of cool, right? Before it was like, if you're one of the top contributors, you get access to a box. And then once we have the new machines, it'll be like, pretty much all the contributors get a box, and the top contributors have access to several machines for running experiments. That's the goal. They will be expensive, though. Donor. There's no donor. There is no donor, my friend. This is... I will be covering all the machines. Puffer is officially a company after all. It's not a not-for-profit, even though all our stuff is open source. So the way we make money is just by selling service packages to people using our stuff. You want us on your side to make your RL fast and easy, you can do that for a reasonable price. Starts at $10K a month. So like a quarter of an engineer to have your RL not be insane and cursed. Pretty good deal. If any of you watching have industry problems and need RL to work for you, give us a ring. Well, it should be 1D, but given away to have shape. Okay. What shape do we have? Do we just sum these? I think we just sum these, right? I am going to save RL. This is why I'm doing this, literally. Like, if I thought that all I could do is maybe make like RL 10% better, I wouldn't be doing this, right? I wouldn't be spending the rest of my 20s on like some crazy mission to make RL 10% better, right? The goal of this is I think that we can fix the whole field of RL. Um, the progress in the last year has been crazy. I think by the end of this year, you're going to see it pretty broadly applicable to a bunch of industries, and we're going to actually start scaling, some contract work out so we can get Puffer going, at a reasonable scale. And then the year after that, by then we just have everything solved, and we get like some much larger contracts, and we are just like a nice, stable, mid-sized industry lab. That's the hope. And the key is to do all of it bootstrapped so that we don't end up with strings attached on what we can open source and what we can't, because we kind of just want to open source everything. Wait, what's wrong with this? What? Um, huh? I don't want to do list to this. Does anybody know how this stupid thing works, this weighted random sampler? Maybe we just go read the source code. Oh, it's just multinomial. So we don't need this thing at all. It's just multinomial. Even better. And we need to do abs of this anyways. Oh, that was sketchy. I'm a Cali CC student transferring now, gotten most UCs. Congratulations for applied math. And rejected for CS. Do I think I can make it useful if I take the right class, or does this suck if I want to do software engineering? The software engineering courses suck anyways, so you should be fine. I don't know how the courses work there, because it depends on your university whether you apply to a major or not. Like Stanford, you do not apply for a major. In a lot of schools, you do not apply for a major, and you can just take whatever you want, and including stuff outside of your major once you declare it. So I don't know if that means you can take 0 courses or whatever. Hopefully you can still take a couple courses, but usually outside of the intro CS courses, which are just there to make sure that like you've heard of all the basics, CS is very much a self-taught discipline. Like the courses suck. So you're not really at a disadvantage for not having access to those courses. If you're a math heavy person and you want to lean into the math, that's cool. I didn't. I'm more engineering heavy, but that doesn't mean that I spent my time taking a bunch of CS courses, right? It means I spent my time doing a lot of projects and a lot of research. Our expanding RL algos pool, what's coming next? So our goal is not to have a pool of algorithms. It's really to just always have the one best algorithm. So right now I'm adding on to PPO a prioritized replay buffer that should make quite a large difference. We're going to test it, obviously. We're going to test it on all the different puffer M's. And actually, as a fallback, there's a way to do training without a replay buffer as well. But the goal is not to like keep expanding this thing horizontally with more algorithms. The goal is to just get the best algorithm, make sure we have the best algorithm, and just keep pushing that way. So right now, we're currently just attempting to improve the best algorithm. Thanks, appreciate your insight. We'll just keep self-learning projects as I go and be fine. Yeah, and if you're looking at RL specifically, there's a quick start guide on my website that does not assume you have a ton of math experience. It links you a very manageable number of papers and blog posts to read to get you up to speed on most of the basics. This is what I've given to all our new contributors. Most of them came in with 0 RL experience. And now I would put I bet on many of my contributors over like top CS PhD students in order to get RL stuff done. So yeah, you can learn stuff. The thing that's hardest, honestly, is getting the good engineering base, but the courses don't help you. Like, becoming a good programmer is very, very, very hard. It's much harder than basically anything else. I consider it harder than like getting good at AI even. But the courses aren't going to help you there anyways. So yeah, definitely don't fall for like the, oh, no coders next year or whatever. Like, no, the coding is the hardest part. It's the hardest part. Everything else is pretty easy, actually. The AI stuff is not that hard. Executing on everything with good engineering is the hard part. Cool, so that looks good. I have lots of programming tips as well around, if you just sort of see with this stream. Tuple has no attribute flatten. Expect values. How'd that happen? Screwed that up. Heck happened there? Oh. Yeah, that's gonna screw you up, isn't it? Some do this. I'll do it. We're gonna comment this for now. Accumulate mini batches. What do we do this? I guess this is epoch then, right? No attribute B returns. Yeah, so that's going to be a problem. I guess this is just like advantages plus values or something. Want a new dev. I want to dev a new env using your C or Python API. Which env has the most straightforward template to follow? Squared does. And there's a little bit of there's a little bit of subtlety here because we're in between two env binding generations. So we're between generations of the way that we plan to do this stuff. So if you just go to 2.0, PufferLib Ocean Squared, there is a full Python implementation of squared somewhere, pi squared. So this is the whole env written in Python. Very simple env. And then there is the exact same environment written with just a binding through Python bind, and then the whole logic is in the .h right here. So you have both as examples. Now, in the new dev branch, which is not done yet, we have found a way to eliminate Python and substantially improve the ease with which you can bind stuff to C. But that's not quite ready yet. You can look at it in the dev branch. In fact, I'll show you real quick. So instead of writing a Python file, this is what you write instead of Python now, and the rest of the code is just about the same. But aside from that, all the stuff in 2.0 is stable and easy enough to use. And a lot of this unstable stuff is going to get stable really quick. I had like a bunch of stuff going on in the last few weeks, and my family was around, so there was time loss in between doing stuff. I should be able to get some really solid hours in over the next few weeks, so a lot of this stuff should just get stable fast. Really, like most stuff in PufferLib is just straight up bottlenecked by my dev hours. Advantages plus values, yeah. And probably we failed to increment global step or something. This is what happened. Yeah, this didn't get reset. So this has to go into sample. Or actually not into sample. It should go into, I guess it goes here for now. Boom. Cool. 2.1 million SPS. Probably it's not doing enough stuff in training, but doesn't immediately crash. Pretty cool. It's not going to train well, but that's not bad for a first draft. Not bad at all. So next thing is going to be experience prioritization, probably, right? Experience prioritization. Notice obs, actions, and rewards are in uint, 8, int, and float. Yeah, you can have them be different D types. So that specific environment, the reward is, I mean, in that specific environment, it is better to have uint 8 because it's lower bandwidth. Other environments have different D types. You can define whatever D type you want, right? Does Puffer handle that automatically? Well, when you're writing your environment, if you're writing it in C, it's going to have a D type, right? And then the only thing that you have to be careful with, which Python should tell you if you're doing it wrong, and our new code should also tell you if you're doing it wrong. You just have to make sure that the NumPy array that you pass in matches the type that you've assigned in C. Which all you do for that is Puffer will take care of that for you, provided that the observation space, right? When you define observation space, you define the correct D type there. So if you look at the other M's, we have obs that are ints, we have obs that are floats, we have whatever. And actions can also be floats if they are continuous, because we do have the continuous support as well. Okay, how do we want to populate the prioritized buffer? I guess all we do, we take this little piece of code. Do we have to copy everything over, though? That's kind of gross. What if I just do, like, prioritize? Well, I'm going to be able to make this simpler anyways. So I think I just do it for now and I don't worry too much. So we do this bit of code here. Oh, you don't need a weighted sample. I'm dumb. I don't think you need a weighted sample at all. We'll do it like this for now, but to learn, just do reprioritize experience. So now we have advantages, compute JE. Then we have to do so this is a mess, but it's not going to remain a mess. No set off policy rows. Namespace has no. This is x dot. Namespace. Okay. No attribute rewards. Log props. Duns. Actions, log props, duns. Obs, advantages, values, returns. So it's these things, right? Obs, actions, log props, duns, values, returns, something like this. And I guess these don't get calced either. They need to get calced though, don't they? Yeah, so we'll just add this to the sampler, right? Okay, so experience values is bigger than advantages here. Let me see why that is the case. Duns. Why is duns smaller? experience.duns. This should not be smaller. Num rows. BPT horizon. So it looks to me like these shapes are getting messed with. Okay, so it says that duns is actually, it's supposed to be the bigger of the two. Yeah, so this is 16K. Still correct. Advantages and values. Very odd. Very odd indeed. Hang on. Duns equals x.duns. That will screw you up. Yeah, you don't need that anywhere else. I think that's it. I think I just had a little bug. I'm gonna have lots of bugs to fix with the code being this messy. But we're almost to the point where we can start cleaning it up. And there we go. Okay, so this is probably not working, probably super buggy, probably very bloated, but this is an implementation of prioritized experience replay in PufferLib with PPO running at 2 million steps per second. That's very good. Now, there's so many things that I'm going to have to think about on how to fix this. I guess I can start by just removing stuff that's no longer needed. This is gone. We still want to be able to do this with P3O. It shouldn't be that hard to like make it work with P3O either. But we're not going to fix that just yet. What about episode indices, episode lengths, and all of that? We still need these? I believe so. I believe we still need the indices. Easier than before, but we still need them. So what was it? Compute JE. Duns, values, rewards, stored indices. See if this gets simplified at all. No longer need stored indices. No longer need this. Need stuns, values, rewards, gamut, and lambda. Should be good. So get rid of stored indices from here. See what I did wrong here. See if this works. Yes. Now we have this running. See if that still trains or still runs. Not going to train just yet. 1, 2, 3. Oh yeah, I forgot to fix it in the other spot. Okay, so this runs again. I don't think that there is any way around all these indents, unfortunately. I guess I could combine them. That doesn't look good. This is gone. What do we think it's going to take to get this thing to train? That would be the most useful, is if I could actually have it training. So then as I refactor stuff, I know I don't break it anymore. Let's go take a look. Okay, so this is the current observation. 8192. Mini batch size is 8192 samples, not segments. One nine two samples. This should be mini batch. Yeah, so now it's 64 by 118. Or was it 128 by 64 by 118? That's way better. And now, instead of update epochs, it's no longer update epochs. Okay, that's a good question now. How do we want to rewrite this parameter? Train steps. It's no longer update epochs, it's updates. Do I want to have it as a factor? I guess I can punt on it for now and just adjust the parameter the way I know it needs to be, right? Because right now, so it's BPT, or was it mini batch size 8192 with one update epoch. Whoops, so this is going to be 5.24288 over 8192, 64. So it's technically 64 update epochs. It's really 64 updates, not epochs. It's the total number of updates that you run. Let's see what this does. It's a lot closer to the original speed. There's no way this thing is just going to train already, right? I mean, I'm not complaining. Did I seriously just do this whole thing zero shot without making any mistakes? Looks like it. Looks like I did. It's pretty close to the original learning curve as well. Okay. So we have a working demo. At this point, I should make a commit before we break it. I guess it's mostly going to be cleanup time now, right? Like, the main issue with this file is it's a mess. And all the stuff I do want to do with experience buffer, like, I don't have much confidence in this file right now, like, that everything is correct. So that's going to be the next stage. Yeah, that's going to definitely be the next stage. Okay, it is 1:24. I'm going to take a couple quick minutes. I'm going to grab a drink, do whatever, and then I will be back here and we will figure out if there's anything we can do with all these crazy messy wrappers, how much of this like redundant stuff we can delete, if there's a good way to clean up the experience buffer, we'll figure out all of that. Okay, I'll be right back. Okay. Good progress so far. There are kind of a couple stages to this cleanup, right? The first one is going to be the big stuff, like can we not have everything indented under 4 layers of with statements because of profiling? Can we clean up the way that we have the experience buffer? All that sort of stuff. And then the second was going to be like the smaller line by line stuff. Yeah. That's going to be the main thing. So I think for now what we do, go a little slower. We look at how indented the code is. And we see if there's anything we can do to not have it be like that. So the first one is the AMP context. Can that be a decorator somehow? I don't really like decorators, to be honest. It's kind of what I did up here, right? This is like the overall profile decorator. Maybe we can do that. Now to turn PyTorch AMP with AMP text to a decorator. I don't know if I'm going to want to do this. So you do something like this, right? But isn't the autocast doesn't have a D type? Well, I guess you can make it up here, right? So you can make like some little wrapper. Do I want this mixed with my profiler though? Okay, we'll keep that in mind. So this is hiding one with statement here. This is another one. And then aside from that, there's one additional layer, right? Maximum of one additional layer, because you never have nested profilers. But there are a lot of them. You see? Now, if we move the CUDA synchronize into the profiler, that gets rid of all these little statements. We could do that. And we can remove it as well dynamically, which is easy. So that gets rid of a little bit of code. What do we think about this generally? I mean, like, tabbing this under a with statement is the correct thing to do. It's just, it's not so nice, you know? What's our profiler code look like? Pretty garbage, right? Pretty garbage. We also have utilization in here somewhere, right? This isn't so bad. So if we kind of just like scroll up through this big chunk of code is the dashboard. This is actually pretty compact for what it is already. The dashboard is just, it's a pretty complicated object. It's kind of manually laid out. This is a seeding function. We've got this rollout function, which will get a little bit simplified. We've got checkpoint loading and saving. We've got this utilization. The experience buffer is a big one. We actually will be able to remove, at least for now, we'll be able to remove this. We'll have to put it back in with P3O. I think actually I don't want to remove it just yet because I want to be able to port that stuff up. Creation here of this can be simplified a little bit, maybe. Oh yeah, this can be simplified. At least a bit. And then, yeah, profiler is pretty bad. Log. Distributed. This doesn't get used. We were considering doing stuff with this though. Definitely some just stale code will be able to just straight up delete with no issues. Stuff like this, you know, instead of writing all these out, we probably can do something with it. And then a lot of this is also like algorithm options. Let's look at the indents in here. So here we have train, epoch. Are we missing the AMP context here? I think we're missing, oh no, here it is. Here's the AMP context. This can just go around the whole thing, I think. You can just go around the whole function. I wonder if there's a way to just do AMP globally. Because you don't want to have it globally, right? Right. MP forward. So you can't just put this to the top. It has to go into this profile wrapper, okay? So then, I think no matter how I do this, I have one layer of wrappers, right? Which will be the profile wrappers. All these little if statements are going to get compressed anyways. I could start with this, changing the profiler, and I could see where I end up. I think that's not a terrible idea. How the heck does this even work? Each of these is actually a PufferLib.utils.profiler, I see. So wait, when you do... Yeah, so it's with PufferLib utils pro, I see. And then you just have them all written out. So I guess the initial thing that would be very easy Okay, so now this should synchronize CUDA everywhere. And then we can do context. If decision guess we just do this. So now how do we like start and end on a context like this? Okay, so now that's the context handled, right? And then we want to pass AMP context. All right. So I guess we'll figure out which. But this should let us fix a whole bunch of stuff. Because now we can just unindent all of this, right? Unindent all this. And I can also do this. So that one might still be needed. But all these that are train related do not need these. Okay. Misc. Okay, so most of that should now be good. See if we can get this to run. No attribute sync CUDA. Sync. Okay, this runs. Looks like it still trains as well. So that cleans up all the context about as much as we can expect, right? Like, we're not going to be able to get rid of these because we need some way of timing individual blocks of code. And it is cleaner to just indent one level than it is to try to keep track of like start and stop, right? So the only thing we can kind of do is we can maybe optimize like where these blocks are getting declared a little bit. Maybe we can optimize like a little bit there. But I'm looking at this eval forward. This can go here. Yeah. That's pretty much as compact as it's going to get. Some of these if statements are, again, these are going to get compressed, so don't worry about those. Just worry about like the overall indentation of it. This is min indent level. One indent level for decorators like this. That we maybe can fix. Okay, this is already a fair bit cleaner. I think the next biggest improvement is going to come from the experience buffer refactor. So let's look at that. How much does TensorDict do for us here? We also need to look at this create function. This is like kind of fine, right? I make the init a little easier if I put this into a class. Man, it's so hard to capture like the clean RL vibes, you know? Cost is just really the goat. It's like every time you try to think of adding some structure. I guess he did eventually go with a data class for args, but that's literally just arg parse, and outside of that, there's a class for agent, and then the rest of it's all just this loop. Man, this is like such good code. How do we like get back to this? You know? How do we get back to this? Every additional piece of modularity that I add brings us farther and farther away from this beautifully simple code. Hundred lines of code. What do we have that's adding to this? Like, does experience buffer even need to be a class? Well, there are a few things that we had to do here, right? Like, that make this a little harder. So the first thing was, you need to be able to call eval and train separately, right? Yeah, you need to be able to call evaluate and train separately. Right now I have 3 separate functions for this. I've got essentially a class without a class, and I have eval and train, but then I also have this separate rollout function. Every feature that we add makes this harder. But what's even harder than adding a feature is adding an optional feature, right? Unless it's just like a smooth parameterization where 0 is off. How I design this is going to depend heavily on how many features I expect PufferLib to have, a few other things. I really, really want to get back to something closer to this, though. I'm going to sit here and agonize over this as long as it takes for me to find some way to get closer back to this. But I don't have to sit here and agonize all at once. That would be very boring. Doesn't have to be all at once. I think for now what I do is I avoid going more in the direction I don't want to go. So for now I don't make this a class. I leave this as is. I just see if I can locally clean up the experience buffer a little bit. And then we clean up and prune code that doesn't need to be there. And then maybe that'll give us some additional clarity. Maybe that'll give us additional clarity. With the knowledge that a lot of these conditionals are going to get deleted. Hey YouTube folks. This is currently me adding prioritized experience replay to PufferLib's PPO implementation. That is the goal here. We have an initial implementation that seems like it works, and now the goal is to clean up the dev branch code so it's actually usable with the new experience buffer. I mean, pretty much all these tensors are, like, these are almost all the same size, right? So I don't necessarily have to go to a tensor dict immediately, but it would seem like we should go to a namespace, right? That we can iterate over. Maybe we can go part way. So this is going to add, some redundant code. We don't need all this. Ops actions, log props, rewards, done, truncated. Okay. So now we do store. Advantages, values, returns. Did I miss advantages and values? Yeah. Advantages. Should these even need to be in here? I don't think the advantages should need to be in here. What about returns? Iterating over these keys seems worse to me even somehow. It can't be though, right? Just do it for now and then we'll see how it looks. Okay. Let's just port up this P3O stuff as well. The returns, it was advantages plus values. Alright, that's not bad. I think that's it, right? Returns, mean standard deviation. All these stupid transposes go away. And we should be good. Oh. Oh, diversity all you need as well, this one. But that's not bad either. This goes away. I don't like the dict indexing, but we will, we'll deal with that. I think I can do, well, we'll get to it. So that's sample cleaned up. See if it runs. Attribute advantages. See if that still works. If so, we should be able to clean up the rest of it. Try this next. Namespace, no attribute namespace. Okay. See if that breaks anything. Do we think we're ready for CUDA? CUDA GAE? It would be simpler and a bit faster. I think we just chill for now. How much complexity are we left with here? A lot of it is just from all these various different choices, isn't it? Okay. Yeah, I think we're on the stage where it's just got to be a lot of fiddly line by line. A lot of just fiddly line by line edits. Try not to break anything. Try to shorten the code, all of that. Is there any way we can avoid having to recall the advantage code at the end? I think not, but I think that we would have, like, we could simplify it if JE were part of the buffer. Does that make sense, even? To have JE part of the buffer? It bothers me. Definitely bothers me. How much stuff does this buffer have that we don't even need, right? So could all this stuff just be part of create? You know? I think it could be. That's an interesting idea. So what if we didn't have an experience buffer class, but did kind of have like a trainer class? Well, we don't have to make the decision on a trainer class. We can just stick it in data for now, right? That seems better. No experience component. That seems quite nice to me. Seems very good to me, actually. Let's just take all this code. Let's just move it right here. Obs dtype, action dtype. Does this even get used lower down anywhere? I don't think you'd even get used. Yeah, no, it doesn't. You get the D types here. See this next row. It's not bad. Experience equal PufferLib namespace. Obs equals this one here. And what I break here. Yeah. LSTM total agents is just total agents. And then you just need all this mess, right? Where's hidden size? Archive, skills, and batch. Config, archive. I don't know what this is. It totally screwed that up, didn't it? Don't ever trust the autocomplete. And then skills is randint, archive, agents. Yep, that looks good. Batch is zeros. This is batch size. Something like that, right? Something like that. And what is this batch size thing here? Config. Just do batch size config, batch size, and device. Yeah. Just for now. And we'll keep cleaning this up. That takes care of it pretty well. Now you just need all these checks, right? Config mini batch and then config max mini batch. And we do the same thing. And that's pretty much all there is in there. Mini batch size, mini batch rows, device, pointer, and step. Do we even use pointer anymore? We'll set him just in case. Cool. So now we take these functions and put these in a reasonable spot, which will probably be below eval and train. Would be a good spot. Do experience X. So we're going to end up typing this a lot. This is going to be long iterative process, I think. Actually, hang on. Let's not screw this up. This is actually data. It'll be data. Where'd GPU ins just go? Oh, it was never, okay, that's fine. And almost, this is no longer data, this is X. It's gonna get messier before it gets simpler. But it is gonna get simpler. Let's go back up to experience. Make sure we're not doing stupid things. Delete that massive mess. Yeah, see, not all these things belong here. All these things, these go to self. These we can punt on for now. This is definitely data, though. Or what is it, LSTMH? Okay, so now all these things need to go into here, which is the annoying bit about how we have this right now. What else? Mini batch rows, num mini batches, any other stuff? Oh yeah, there should be a bunch of things. So stored indices, app lengths, app indices, free index. Namespace. Index. This is data, and this is data. Yep, so this on policy and off policy rows. Like I say, it's gonna get weird before it gets easier. Ops. Ah. You left trailing commas on literally everything. Namespace, no attribute device. Really? Well, we'll just add it for now. Making a huge mess of this, but this is necessary for now in order to get it to a point where it's cleaner. Do we have config here? Do not have config? Num mini batches. I thought that we had this. Oh. Now data. This gets us at least closer to what I want, which is not a whole bunch of separate little utility classes. And this is a sample. Data. Data. Okay. Into object. I probably left some stuff in here that's not supposed to be in there. Pointer and step. That's not supposed to be in there. Broke my terminal. Okay. Equals sample data. Experience dot items. We'll see how that goes. Just a whole bunch of renaming of stuff required for this. Hopefully we didn't break anything, we'll see. Yeah, run the same speed as before and hopefully nothing broken. So now we have the entire big experience buffer inside this create function as this massive, like, not super massive, honestly. Where is it? It's like a screen and a half of code. And mind you, a lot of that is for the different algorithms. So this is going to end up being like less than a screen of code for the experience once we get rid of extras that are not needed. So that's not bad. I'm still going to be stubborn for now about not making this a class. So we'll just endure having this stupid namespace for now. But hopefully this allows us to co-optimize a few things, since we no longer have multiple different structs hanging out. I think the next thing will be to approximately fix all the algorithm add-ons, like these like E3B, diversity, all you need, all this stuff. These code blocks are no longer in the correct place after we've made these changes. So we should probably fix that. And then we can play around with the experience buffer itself and how we want that to work. Probably will need some more logging. I mean, there's going to be a lot of cleanup here, right? This file is just massively too long. This is a 1200 line file. This needs to be a three-digit line file. For sure. I know how to fix that. We also have the option to do CUDA module for generalized advantage estimation. That would probably be a good idea. I think we'll time it first to make sure that it is actually an issue, because, well, it's probably not getting profiled correctly yet. All right. I'm gonna use the restroom. I will be right back. I gotta do one or two other quick things, and then we'll be back in a few, and we'll continue cleaning this up, and hopefully we at least have a reasonable working prototype of this today, with additional cleanup to continue tomorrow, and then by midweek we should already have, end of midweek we should already have something that looks pretty good. Right back. Few minutes. Alright. I just have to put in a food order, and then we'll be back. The plan is going to be I do super early dinner today. So I work on this for the next hour or so. And then I grab super early dinner. I get a little exercise in. And then I should be able to come back for a short evening session as well. Just figure out what I'm getting. We'll do that. Harvest it all on that. Yeah, don't really need carbs. Alright. But do we want to do CUDA advantage already? Let's see how hard it would be. Doesn't look like it would be that hard, right? This is what I had for P3O. So we should pretty easily just be able to do this for PPO, right? Okay, so this is going to take float star values. This is going to take wards. Oh, it also needs duns. it like this maybe. Values, rewards, duns. Float. Is it? Float gamma, lambda, and then we also need num steps and horizon. Okay. This is going to be row parallel, right? Yeah, this is one row. Literally, it's just this operation right here. Oh, you probably need the advantage buffer output as well. This. The x row times horizon plus t. What's it? Row idx plus 1. So this is idx next. This is idx next. Oops. I only want the single term autocomplete so I can make sure it doesn't mess anything up. Delta. Rewards next. This is fine. And then advantages of IDX. Look at this. Boom. Okay, so this is roughly what our kernel should look like. Was it C advantage? Where's the binding? Dot C. Not this. Can't be this either. Okay, hang on. Where's this load? Okay, load PufferLib.cu. That's what I did. So this is what I did. I just need to get the signature for this and we'll be able to fix it. So this is now called P30 kernel. P30 kernel. Now this is P30 kernel. All right, and now this one here, torch tensor values, rewards, duns, advantages, and substance horizon. Cool. Okay. And this is going to be JE kernel. This is JE kernel. Very nice. We do a little CUDA now and again. You know, we do a little bit of CUDA now and again. Start with this. We will just like redefine this thing because we'll need this later. So this is compute. And I'd love to figure out how to reduce the amount of binding nonsense that you need for this. But yeah, for now we're just going to do it this way because it'll still be faster. This is where is it? I copied the wrong one. Stupid. Need the signature. You know, I really haven't written much CUDA, but it turns out if you're used to writing C, CUDA is just C that runs on the GPU. Kind of no big deal. Honestly, dealing with the stupid binding module is more of a pain than writing the actual CUDA. Assuming you're doing, you know, embarrassingly easy stuff, if you're just doing row parallel or whatever. Obviously, they're like complex block parallel schemes. We don't get into that, but you don't need to most of the time. Okay. Just got that. Steps. Signature. How the hell did it cut a parameter off? Well, I wasn't looking at cut a parameter off. You see that? All right. And num steps and horizon is actually launch kernel. Now we get to actually use the torch tensor for this, right? So we just do compute JE, rewards, duns, advantages, gamma, and lambda. Isn't that nice? And then we do the same thing right there. Sure. What did we screw up? Just some stuff in the CUDA. You forgot semicolons on literally everything. What a noob. And didn't you even forget? Yeah, you forgot this too, you noob. Okay. That's what I get for coding CUDA with no LSP or anything. I probably should have an LSP. Int num steps. Forgot this comma. Expected opening brace. This block. This is added for you, isn't it? Oh. Duh. Alright. This is just duns. Wait, PufferLib. I messed it up here as well? Yes, I did. JE kernel's already been defined. Forgot to delete this nonsense. Okay, that looks worse. Wait, def JE kernel has already been defined. Does this have to be a different name? Oh, this should be compute. This should be compute P3L, right? And this can be compute JE. That way it doesn't conflict with the kernel name. Still no? JE kernel's already been defined. I only see it once. This compute. Hang on, I don't know which one of these you load. PyInit compute JE has already been defined. Torch extension name. M. What would that be caused by? Hang on, do I get it for both of them now? Oh, it's a single m.def, isn't it? It's probably a single m.def. Can I just do this? That's probably better, right? Cool. So now that actually compiles, and the only thing that I get is this warning, which we can just comment this variable. Then was it cannot access X? I don't know how I do that, where I just accidentally delete a massive chunk of code. All right. Does it work? Does it work first try? We shall see. You need advantages, right? Yeah. Let's do it this way. Oh, that's way faster, isn't it? Yeah, that's way faster. So I don't even have to check if the C implementation was slow or whatever, because it obviously is. That's good to know. And yeah, we kind of immediately just win with that. Kuda very fast. Okay, so we still solve breakout now with this. Good time to make a commit. There you go. CUDA kernel done. So now it's mostly just going to be a matter of cleaning up the rest of the code and then actually like figuring out how the replay buffer interacts with all this, right? It's 3:22. Okay, I'm probably gonna have dinner. I'm having a really early dinner today, like probably within the next half hour. So I'm just gonna keep working on that until then. And get dinner, probably get a little bit of exercise, and then I'll probably come back for an evening session. It's the goal. So I think for now, what we do is we just start cleaning this stuff up. So this bit here, whoops. This goes up to here. We indent this. So this is now experience values. Yeah. Okay, this gets easier. So this is now data.massBlock.0, data.buff.0, data.rewardBlock. This is now experience.rewards. Experience.this. And then advantages is not stored here, I guess. Data.bounds.0. Get rid of this. What did I just do? Just double dot. Okay. It's probably something around like this, right? Don't need these anymore. This is experience dot. I don't even necessarily want this to run just yet. We don't need this flattened batch either. Okay, well, I don't even necessarily want this stuff to run just yet. Yeah, I just want this to be like roughly in the right spot and the right size. And we don't need any of this. This is not experience.values.flatten. This is batch.values.flatten. Okay, we make sure this still works. Slowly but surely, we are cutting off lots and lots of code. I don't know why this is here. This can just be okay, that still works. Let's try this now. I don't know why this is a separate function. Oh, it's because I see it gets used in both places. Fine. We'll leave it alone for now. But we are going to get rid of that. Okay, are we ready to take a look now through this code and see how this is overall? So we have our bindings. The bindings are messy. The bindings will improve. We've got this create function. It's got a giant block of stuff for allocating experience. Most of it is like extra algo specific, so a lot of these things will be gotten rid of. Here's the rest of init. We have this crazy messy namespace thing to think about. That's lower on the priority list. What I really want to see is like evaluate and stuff like this. So profile eval missed while not full. Profile the env, get that. Here's the first little snippet from diversity all you need. Eval copy. LSTMH indexing. Forward with the state tensor. Okay, so most of the like extra crap here is just from the new algorithm like components. So these will be the goal will be we will finish testing these and then we will either keep them or delete them. And then actually the loop will be pretty clean with possibly some small, line by line fixes that we need to make. Then we have train. PG. Do we use this? No, we don't use any of these. Logging stuff will have to be adjusted. We do P3O, and there's PPO. Yep. Here's your train forward function. So we're pretty much back to like some line by line changes plus the main thing being the main thing being the algorithm add-ons. Okay, this is good progress. That might be dinner. Let me go check on something. All right, that's dinner bell. I will be back probably later tonight after dinner to continue working on this thing. If you're interested in my stuff for RL generally, I've got a pretty pretty full streaming schedule the next full weeks. Going to be streaming a lot of dev. So Puffer.ai started the GitHub repo to help us out. That really helps us out. It's free. Just do it. Can join the Discord to get involved with dev. A lot of our best contributors came in with 0 RL experience prior. It's a great way to learn. And you can follow me on X for more RL content.